thanks everybody for spending the next 50 minutes with me, because my talk is all about the best practice that we have distilled from looking at the 400,000 or so open source projects hosted in Maven Central. And there's some surprising lessons that you can actually learn when you start looking at software production at that sort of scale, because it's actually a really interesting analogy and an analog. So first of all, who am I? What am I doing here? Why am I preaching you about this? Well, hi, I'm Ilkka. I'm the Field Chief Technical Officer at a company called Sonatype. So before anyone asks, it's not SonarQube. Got nothing to do with it. Actually found it in the same year as Sonar Source. But what we do at Sonatype is something I say to everybody who goes down to the stand over there: to use Maven. Have you ever built Java software? If so, you will use us. We're the people that run Maven Central, the repository that powers everything, every Java dependency ecosystem, every Android dependency ecosystem. We've operated it since its inception. For the last 12 years or so. We do it as a free service to the community. And as anyone actually working with Apache will be quick to find out, we are the stewards of it, not the owners of it. So we help maintain it for the community, and in exchange we look at the data that comes out of it and share the lessons to the wider world. Myself, I work with our customers, then taking that open source in and talking to them about how to manage that open source, what to do with it in order to be productive. And again, that practical lesson kind of gives you quite a lot of insight. So for my talk today, what I wanted to do is share some findings from a report that we produce every single year. So if you want to spoil yourself and save yourself 50 minutes, just read that. You'll learn most of the things, but you missed the color commentary. The report is something that we do every year. We've been doing it for 7 years running. Every year it gets a little bit bigger, it gets a little bit more interesting. This year we looked at over 2.2 trillion, that's 12 zeros, open source downloads, and over 4 million component update events to get a sense of what is it that makes people tick, first of all, with open source. Secondly, what is it that, what are the good practices that we see when it comes to that? So by the end of this session, hopefully I will have imparted some of the lessons, kind of counterintuitive lessons that we've learned from this year's report, and hopefully that'll give you some tips on what to do best. So let's start. If you're going to be looking at open source, it's good to understand define the boundaries of the test data. So let's talk about open source. For the State of the Supply Chain report, we look at open source at large every single year. This year, we looked at the 4 largest ecosystems out there: Python, JavaScript, Java, and .NET. In order of magnitude, JavaScript trumps it all. npmjs gets about 1.5 trillion downloads every single year from its repositories. Quickly followed by Java. Java is the world's second largest open source ecosystem as measured by download volumes. It gets almost 500 billion. That's just 9 zeros. That, quite a lot, but not 12 zeros big. 500 billion downloads on an annualized basis. Followed quickly, it tapers off. Python, the next largest ecosystem, only has over 150 million or so downloads, followed by .NET, which is the smallest. But what's pretty interesting about each and every one of these is that they have kept growing every year since we started running these stats at least a pace of 60% year over year. There's a hell of a lot of open source out there. In fact, there's over 3 million distinct projects, and on average, every single project has at least 10 versions available for people to use. That's over 37 million, which is over 10 versions on average. Which means that as developers, we're spoiled for choice, right? We have quite a lot of work to choose from. So choose we do, because today, as we all know, since this has really been the year of the supply chain attack, we've all heard about attacks of poison packages and upstream events and people putting ransomware and all these sort of kind of cool things. Today, the average software application is about 90% third party. On average in Java, about 106 open source components, JavaScript projects, you can easily see 300 or more modules. Only about maybe 100 of those are typically direct dependencies. Most of them come in transitively because, hey, I rely on open source, that open source project relies on other open source, relies on other open source. The transitive chain typically runs at least 4 or 5 levels deep. So that table is cool and all. You can look at it in the report, but I find it easier just to dive into some of the select sets of data. First of all, kind of obvious lessons that you see here. The amount of open source is growing, the actual new projects that are being published is growing at about a pace of 25% across all the open source ecosystems. There are about 25% of projects this year being published into Central or published into npmjs that didn't exist last year at all. Now, as we know, it's kind of just like in any other publication, it's kind of a chance whether or not that becomes available. But what's pretty interesting also is that about 25% of the versions that didn't exist before will be published this year. So as developers, there's quite a lot to handle, right? You know, if you think about a singular application, about 100 dependencies being pulled in, it means that we have quite a lot of volume because each and every one of them will be publishing on average at least 2.5 versions this year, so we have to keep them maintained. From a download and growth perspective, the first kind of interesting lesson is the world's fastest growing open source ecosystem at the moment is Python. The slowest growing ecosystem is JavaScript with npmjs, but npmjs only grew by 50% from 750 billion to 1.5 trillion annualized downloads. So this doesn't quite tell the full scale of magnitude of the open source that's being consumed. By and large, the average growth rate across all of the open source ecosystems is just over 77%. So what that tells us is, to me as a developer, it feels like open source is old news. It's existed for, 30, 40 years now. Everybody uses it. There's like no question about that being diagnosed. But what this seems to imply is that the world at large is adopting either software development more or adopting a lot more open source itself compared to what it has done before. And there's no signs of stopping. In fact, the pandemic only increased the rate of growth. Last year was about 60%. This year, it clearly jumped. So kind of makes sense. We're all at home. We're writing more code. We're going to have to borrow some code from other people, so we're downloading more of it. And that's happening across all of the open source ecosystems that you can measure. Pretty interesting. Let's talk about the scary stuff then. So as we know, for years and years and years, as vendors have been telling you, not all open source is good. Some of them contain security vulnerabilities. Unfortunately, that's a fact. Some of us even make a living out of it. But one of the first interesting things that we noticed when we looked at this data of open source being available is ask the question, where do the vulnerabilities actually exist? If there is a known security vulnerability on open source, is it a popular project? And kind of an obvious answer, more popular projects which have more downloads typically have more known security vulnerabilities. Actually, by quite a high margin, about 25% of all popular open source projects have security vulnerabilities. But if you look at any of the other projects over here, less popular versions of the same ecosystem, you'll notice that the vulnerability density decreases quite heavily. The red bar signifies how many vulnerabilities are there in the most popular segments. So it starts off with the top 10% most popular components and tapers off from there in segments. What you notice is more popular projects get more eyeballs, but they also get more hacker and both good and bad attention, which means that on average, security researchers will discover more security vulnerabilities. Developers consuming that software will discover more security vulnerabilities. Conversely, though, it means that the more popular project you have, the more likely it is to be a target for a supply chain attack, either by poisoning the project, finding new security vulnerabilities, and exploiting a campaign that goes out there. Kind of a That in on itself is kind of counterintuitive because your gut feeling is always, hey, this thing is popular, everybody's using it. Clearly, it's safer than the rest because it's somehow of higher quality. When it turns out, no, they on average have more eyeballs, they on average have more things that are being discovered. That makes them very, very attractive targets. This is probably the one diagram that really shocked me when we were crunching the numbers this year. In the year 2020 and leading up to the midpoint of 2021 when we cut this data, we have seen an increase of over 650% of supply chain attacks. That means somebody executing an attack like Code Cove, executing an attack like SolarWinds, executing an attack like, somebody put some crypto miner in npm or something like that, right? All of these things happen. And it feels like this year there's been a lot of news about it. Well, it's not just you. We keep a track of every single incident that we discover, either through automation or either through security research. And this year, that number has grown 650%. That's the reason why you keep seeing it on the news, why every week there's a new npm package that has a crypto miner in it or a ransomware or something like that. It is not just vendors making noise. It's because open source is still growing. Everybody uses it, everybody's downloading more of it. It becomes much more of an attractive target to attack one piece of code that you know is going to spread to 2 million developer workstations. And unfortunately, this is the result. Now, this encompasses all of the different supply chain attacks that we've observed, but by far the most popular one is also the one that kind of gives me the creeps on how easy it is and how effective it is. It's an attack methodology known as dependency confusion, first described by a guy called Alex Berzan in February of this year. He published a really, really interesting blog post on Medium. It's called Dependency Confusion, How I Hacked into Apple, Microsoft, and dozens of other companies. I will spoil his secret technique for you. First of all, go on any company's GitHub page and look at their code. In their pom.xml or Gradle file or their package.json, you will find references to internal packages that are not available in open source ecosystems. Step 2, go on npmjs. Did you know that anyone can register any name in npmjs? There is no ownership verification. So you register that package name. Step 3, create a bad package, something that downloads some passvd files or things like that, and then publish it with this hijacked name, but with an extremely high version number. Let's say 9,999. Chances are that your target company will just download latest, right? Whatever is the latest version. Well, now it turns out when you go through all the indices, the latest doesn't sit in your internal registries anymore or repos. It sits outside in the open source world. So now you're downloading version 9,999 because it truly is the latest available in the indices. That is literally it. No assembly required. Anyone can do it in 2 minutes. And it is brutally effective. Since Alex described it, within 24 hours, we saw over 100 copycats. Within a week, we saw 1,000 copycats. At this stage, when I stopped counting, we've seen over 16,000 dependency confusion attempts this year alone. It was only described in February. Why is that? It's dead simple. There's no verification, and there's no things over there. So here you go. Best practice number 1 and a lesson that I've learned from looking at this data. It really counts to have a 2-degree coordinate system because you can have ownership verification of the group ID. So for example, in Central, I know that many of us feel like it's a bit of a burden to go in. Well, this is the reason why it's so hard to sign up for a Central account. You have to have some level of ownership verification to ensure that somebody's publishing a component that they're claiming to be. This is a really interesting thing to read about. I highly recommend Alex's article because it just describes how simple it is to subvert things. Second lesson I distill from this is that we have a tendency to trust our tooling and trust our automation. And very rarely do we actually check things once you've written it once in the pom.xml. So if you write it down, you typo it once, that can be a bit of a problem. Even if you do, and you don't fix your versions of of what you're downloading, you can put yourself at risk for something like this. Sure. All right. Well, that's scary. There's plenty of other bad open source over there. In fact, this week we just discovered yet another ransomware package that is that exploits npm's post-install scripts. And as soon as you install a package, it has a post-install script that runs without you prompting anything, which installs a ransomware software and plays a really spooky Halloween video, which was kind of funny, and pretends to be Roblox, which is kind of interesting, right? Somebody really going after the kids there. So next question we asked in this year's report was, what is good open source? Like, okay, if there's bad open source out there, we know that popular projects are of less quality from a security perspective. What are there any measures that I could take or any frameworks that I could follow that give me a sense of better open source? Like, give me a sense to a way to measure if open source is good. So the answer is there are quality metrics and frameworks out there. For example, there's the OpenSSF Criticality Index. There's the OpenSSF Scorecard, which is a report. There's also a page called libraries.io. There's deps.dev now from Google. Each and every one of them give you a slightly different measure or flavor or a framework where they say these components are of good quality, right? So for example, libraries.io measures the popularity of a component, which I said kind of intuitively makes sense, but they also measure the maturity of the open source project through various different means, and they've got a little bit of weighing on the activity of that project. Now, the second model that is probably the most popular one is the OpenSSF criticality. OpenSSF, or the Open Software Security Framework, is a Linux Foundation project. It's a group of different vendors that are working together to try and come up with a way of measuring the security of open source. The criticality score really focuses heavily on the open source project's activity. Essentially, they look at how many commits are happening and try and make a statement of this open source is more maintained than other open sources. They also have a bigger framework called the Scorecard, which actually forgoes activity altogether and then measures the maturity of the project and the dev practices. Are they doing PR? Are they doing code reviews? Things like this. So the first interesting lesson to me about all of this is there is no framework that really does it all. There's nothing that really measures everything. In fact, you can't really do an apples-to-apples comparison when you look at an OpenSSF criticality score and, let's say, an libraries.io's PageRank. They're all proprietary. There's very little that's shared within them. So for, as we say, where I'm from, for fun's sake, we thought, what if you just looked at a very simple metric, saying things like mean time to upgrade, and you did nothing but measured how components are maintaining their dependencies? So we came up with a model we call mean time to upgrade. And in its simplicity, it's a very simple model. First of all, take a open source project and look at all of its dependencies. Second, measure how quickly does that project update its transitive dependencies. For example, in this example, let's say project A has dependencies B and C. Dependency B has a new update. How long does it take for project A to upgrade to that new dependency? And then let's say their other dependency C has a new update. How long does it do that? When you take all of those upgrades and you just take the mean time of the duration, you get a number, right? So you just average out all of the upgrade events and say how long did it take for these projects to do that. And we took all of these different models and we asked ourselves, what does this look like at scale? Do these models actually correspond to good security outcomes? So we built a data set. Luckily, we happen to be in the business of helping customers use open source, so we have access to upgrade events. So we looked at a customer data set that had 100,000 Java applications in it, and within that 100,000 application data set, we looked at over 4,000 component upgrade events. So we looked at a project or a piece of software that was being developed, and the only thing that we looked at was, are they upgrading dependencies? If they are, we took a measure of that upgrade. When we ran those upgrades, we classified them into two qualities, like either the high-quality upgrades or the low-quality upgrades. And what we mean by high-quality upgrades is that it didn't introduce a new security vulnerability, as in it was a safe thing to do. But we also said a high-quality upgrade shouldn't have any breaking API changes or any breaking code changes. Because if you're doing an upgrade and it breaks your code, you're burning more calories to do that upgrade. It takes you physically longer to be able to do that. So we squared off these 4 million migrations against all of these frameworks. And here's something really counterintuitive. Like, it is counterintuitive to me to this day. Turns out the only model that corresponds to less security vulnerabilities, less situations where you can't proceed to upgrade anymore because there's no better version, and a place where you do less extra work because of breaking changes. It turns out the best model for open source quality is to just literally count the mean time to upgrade of its dependency tree. There was also a corresponding correlation, not quite as heavy, with OpenSSF criticality, if you remember a framework which only measures activity. So it turns out the best measure for a project security is how quickly they update their dependencies, or how active that project is maintaining its dependencies. All of these other models, although they looked at things like are they downloading, is this being downloaded, is this being maintained, seem to have almost an inverse correlation. And the reason for that was that more popular components tended to have more security vulnerabilities, so there were less good upgrade paths for you to do. So lesson here. It's actually quite simple. Just look at is the project actually maintaining its dependencies? Are they releasing new upgrades? That's a better measure of quality than anything else we've seen. Which is first counterintuitive lesson. Well, the good news is when you square up all of the MTTU scores of everything in Central, hey, good news. We're getting better at it. Most projects are more active this year than they've been in the 10-year cycle. When you count the MTTUs of all of the projects and you average it out, that's the kind of graph that you see. Smaller number is better. So today, the average MTTU is about 11 days. In 10 years ago, it was over 100 days. So it kind of tells you a little bit about how much better through automation we have gotten to maintain our projects. Kind of an interesting thing, I thought. So let's then talk about, okay, that's fine, and that's good in abstract. The next thing we asked ourselves was, what are we doing to keep our components up to date, not as open source projects, but as end users, right? Let's say you work for a company, you write software, which is probably not a big assumption. We asked, well, what are industry veterans doing? Like, are we doing practices that are aligned with this, or are we not? So again, we looked at the data set. We had a pool of 100,000 applications. First thing we discovered is kind of an interesting thing. There are over 430,000 projects, just under 500,000 open source projects available in Central. We only saw about 40,000 of them in actual applications that people were developing in this data set. So it means that although we have this huge pool of things, most of it is never touched. Now, the second thing we did was we looked at that data set of migrations and we asked how many of those open source components actually had an upgrade event, right? So if we have 40,000 projects that are actively being integrated by developers like yourselves, and they do a migration event, what happens? How many of them actually had a migration event? And it turns out only about 1/4 of those components, only about 10,000 of those projects actually were updated. So if that looks a bit complicated, it certainly does to me. The cliff note is 75% of all the dependencies that we saw people using were never updated at all. 75% of the dependencies that you use, you never update yourself. And it kind of makes sense, right? Dependency management isn't something that you really want to do as a consistent activity. It is a process that often is an ad hoc thing. It often is something that we dedicate the minimum amount of time because it is not our job. Nobody wants to deal with dependencies. That's why we call it dependency hell. It's complicated, it takes time, and often it's not planned in over there. And the result of that is most people, when they integrate open source, at least according to the data, everybody in this room excluded, of course, probably only deals with the thing that breaks or deals with the thing that has a fire drill, as in a new really bad security vulnerability. It's all over the news. It's all over our Slack. We got to fix it, right? So this is kind of, okay, interesting, but not surprising, at least to me. I feel like intuitively I'm guilty of this, as is everybody else in the world. So we looked at the data set then and said, okay, are there any rules or any other best practice that we can distill from these good migrations? You know, when we see people doing the right thing and doing good upgrades, are there any things that we can say about those upgrades that would lead you to a good rule of thumb? And we actually came up with 8 different logical rules that help you make the right dependency upgrade decision. Hopefully makes your life a little bit easier in upgrading them. They're divided into 2 categories: objectively bad choices to make and subjectively bad choices to make. Objectively bad choices are things that are just like across the field, just a bad thing, don't do these things. And subjectively bad choices mean they're situation aware. Sometimes you just can't help it, and what's good for me might not be good for you. But generally speaking, those rules are, okay, don't ever, if you're doing something in production, don't choose a milestone or release candidate or any sort of beta version. Generally speaking, they're not maintained. They will not have, they have worse upgrade paths forward. And if there's a security vulnerability, nobody's going to, do a patch, a hotfix for an M version, right, or an RC. That's as simple as that. Secondly, kind of an obvious rule as well, and it's just good to see these written down because they kind of reaffirm some of the common knowledge that we have. Don't upgrade to a version that has a known security vulnerability. Pretty obvious, don't do a bad thing, but it turns out a lot of people still do. Third one is kind of like a little bit more counterintuitive. If you are on a version and you know that it has a security vulnerability, most of the tools, like Dependapod, etc., will just tell you, here's the next non-vulnerable version. Like upgrade to this, there's the next non-vulnerable version. That's not always a good rule to go to because that next non-vulnerable version might be 7 major releases away from where you're at, which means that you're going to have to burn a hell of a lot more calories to get to that version. It's a very, very costly upgrade for you to do, which then causes people to defer that upgrade, which means that they don't do. So if you find yourself in that sort of situation, the best thing to do is go to a version that is at least less vulnerable than the one that you're on right now. Even if you have only bad choices ahead of you, kind of an obvious thing, do the less bad thing. Don't do nothing, do something, and get to something that's a little bit less vulnerable than where you're at right now. Finally, kind of an obvious thing, but kind of interesting to see it in the data. If a component publishes something like 2 versions in really rapid succession, let's say within a week, go for the later one. I know, it's mind-blowing, right? But usually people only do that because they effed up something, and now you have to do a patch, right? So generally speaking, if you've got 2 choices very near to each other, always go for the later one. Simple as that. There are other kind of subjective rules that you can follow as well. First of all, if you know that everybody's upgrading through a certain path, you should do the same. Just for the simple fact that somebody's really probably written a Medium post, or the community forums have more posts about that migration path, or somebody has other opinions about it. Secondly, choose a version that minimizes the work that you need to do in order to upgrade to it. As in, take a measure of the breaking changes, the API changes for the package, and migrate to the thing that's of least work. And finally, choose the version that everybody else is using. Kind of reaffirms that whole choose the path that everybody else is following. Because if you are on a path that everybody else has trodden, chances are that it'll be easier and faster for you to fix those situations. Finally, if all of the above are tied, as in if everything else is about the same across a couple of versions, always go for the newer one because of the previous objectively bad rule. Always go for the newer one because the newer one, generally speaking, is better maintained. If everything in this rule set is a yes, like as in we're not doing the objectively bad choices, we're doing all the subjectively good choices, then in our research, we considered that a optimal migration. We called it an optimal migration. Everything else was a suboptimal one. If somebody did objectively bad choices, we called it a dangerous migration. So we took that 4 million migrations and we asked what happens when you categorize them. And it turns out, kind of, again, not surprising, but interesting, most of the component upgrades that we do today are not optimal. They don't fulfill all of the conditions that we mentioned over there. And what that means is almost 65% of every single migration that we do could be done better, could result in less work for us as developers, could probably be less of a pain and less of dependency hell, a lot more of I'm actually doing things. Good news is most people avoided dangerous decisions. We only saw about 3% of outright dangerous migrations, as in somebody went from a good version to a really bad version. And generally speaking, people tend to avoid release candidates anyway, so it's kind of good to see. But what it does mean is that seems to imply that we are still, as an industry, lacking a good model for doing dependency management right? We're lacking kind of an engineering process. Most likely just happens based on the individual's volition that happens to sit in front of the keyboard, and there's no structured process for it. A practical example of how this might work, I know this is going to be a little bit of a hard thing to follow, but I'm going to try and be the weatherman here to walk you through this diagram. The way to think about it, right, is if we assume that we have a component, it's got a version range from a version 1.0 to 110, right? Let's say you're in 1.1 right now. If we take those rules and we calculate it over all of the versions available, let's say that we land on the fact that version 1.9 is the most optimal version. Most of us won't go for that many dot releases, right? Most of us will say, well, hey, it's a safe bet to land somewhere in the middle or get somewhere over there. So let's say we do a migration to version 1.8. Typically, projects live. We know that they have over 10 versions out there. By the time that you get there, you probably will have other versions available. So now let's say the project releases version 1.11. Now 1.11 becomes the optimal version, maybe because it fixed a bug in 1.10 or whatever. And we're in 1.9, which means that we have to jump to 1.9. Put it another way, to get to an optimal upgrade path, we wasted 2 migrations. We did 2 different update cycles, which probably were backlogged events, which probably means that some poor Scrum Master had to chase me to do it. But it means that we did twice the amount of work that we needed to do. We could have just gone to 1.9 and then from 1.9 to 1.11. We basically did 50% too much work. This scenario is something that's really, really common. Here's the marketing piece. If you calculate all of those together and you assume that you work for an average company, that's about 8 days a year that's being wasted on non-optimal upgrade paths. It's not a lot, but it's still 2 working weeks that you could be doing something else, right? I don't know, reading a book, maybe taking a Friday off or something. But putting it this way just implies that there just simply isn't an engineering process that's standard, that everybody follows, that everybody understands. And that results in more work than is actually necessary when you look at it at scale. Individual mileage may vary, obviously. Of course, everybody here, again, is enlightened and does the right thing. But in general, when you look at the crowd, it seems to imply that not only are we doing poor choices, we're only managing about 25% of what we actually consume in our supply chain. And that 25% that we manage pretty poorly. So, not to shock you or anything, but that's what the data says. But hey, there was still one path that we could take and ask ourselves, what do people think they're doing, right? So we thought, you know what, why don't we run a survey and ask people themselves, how do you think you're doing, right? So what we ended up doing was we asked people a bunch of questions. We said, okay, rate you. I know it's a very, very tiny slide. You can read it in the report, so don't worry. We asked people on a scale of 1 to 5, 1 being the worst, 5 being the best, how would you rate yourself across different actions? Let's say, for example, how you build and release software. How would you rate your consumption of open source? How much do you know what it is? And it's kind of like a maturity model. Over here in 5, we have an engineering process. We're super mature. We're monitoring it. We're describing it. Over there on 1, we're doing nothing. Number 3 is like it kind of happens at the middle line. Is kind of like we're doing ad hoc things. Every once in a while, somebody thinks about it, and then we do something about it. So we asked a bunch of questions about what are you doing. The main point that I like to highlight here in this slide is we asked people, how good are you at fixing security vulnerabilities when they happen? The gray bubble here is the middle point. People below this were in the 50% minority. So meaning that 50% of the respondents were on this side, 50% of the respondents were on this side. So what this implies when we asked people, how good are you fixing security vulnerabilities? Most people said, yeah, I'm pretty good. I'm actually, most of the respondents, over 50% of them, said that they're either in control or with a completely mature process that's being monitored and measured. Also, interestingly, then, is this answer at the bottom here. Are you in control of your open source supply? Do you have a process to manage what open source you download? In this space, most people went, it's kind of ad hoc, right? That's basically what this says. 50%, most people kind of said we're about a free. So, kind of a bit of a paradox here. We think that we're doing really, really well when it comes to managing open source. We're really good at fixing security vulnerabilities. But most respondents, 702 of them, said we're not very good at actually picking them out from the lot. And what ends up happening is when you look at the data, you're actually only touching about a quarter of what you actually downloaded. So not only are you not good at managing things, you don't even have a full process for bringing things in. But hey, we're all really good at fixing the security vulnerabilities, right? So what that really means is that in most organizations, at least when I look at it through my subjective glasses, in most organizations, the process that we have is geared towards fire drills. No wonder, because we as an industry love a good headline. You know, if there's something that's a big security vulnerability, slap a name on it, get it on the news, you know, it's on the register, it flies all around Slacks, everybody panics, and then it's a fire drill. Turns out when we've been doing it for 10 years, we're pretty good at doing that, right? And that's what most people think security management actually is. Again, what that implies, though, is that most of our process isn't really managed. There isn't an engineering workflow that we're following. It's just point in time what we're doing when that happens. So the reality of this is we're very good at reactive security. Most of us, by self-admission, aren't very good at thinking about this proactively. And no wonder, because it's a really complex problem to solve. Like I said, our capacity in most cases, at least implied by the data, only reaches about 25% of what we're using. So of course, the situation with the other stuff ends up being reactive. So kind of a best practice is think about it, learn to understand what's the entire footprint and think about what the process should be. So we then asked, are there any shortcuts that we could give people that make their lives a little bit easier and help them understand or give them any rule of thumbs based on this data? So I'm going to show you one final really hard to read graph, but trust me, it is worth it. We looked at a single open source project, in fact it's Spring Core, and we looked at all the migrations that we saw somebody upgrading Spring Core with. So every time in our data set of 100,000 applications, somebody upgraded Spring Core, we plotted them on a graph, and we asked, what does this tell us? This is what it looks like. It's pretty hard to read, but let me walk you through it because I think you'll find something really interesting. Each and every one of the x-axis here is all the releases of Spring Core from version 4.0 to the latest heads that we saw. The y-axis is time. So furthest out in the future is at the top. Nearest to the future is at the bottom. Don't ask me why we did it that way. It looks better, I guess. But essentially, this is nearest to today. It's August 2021. This is August 2020. And we asked on every single day, every time we saw somebody upgrade Spring Core, we would chart that out, and we would calculate it against those 8 rules that I spoke to you about previously. Were they good upgrades? Were they bad upgrades? If it's a good upgrade, we give it a green color, or an optimal upgrade, we give it a green color. If it's a kind of could be better, but it wasn't the worst possible thing, we gave it a purpley color. And if it's just objectively a bad choice, as in it was a bad migration or dangerous migration, we gave it a red color. The intensity of the color signifies volume, as in on the days that we saw more upgrade patterns, we saw darker greens. On the days that we saw more bad choices, we saw deeper red, essentially. So deeper the color, the more of those events happen. So a couple of instant lessons from this. These gaps that you see here with no activities, those are release candidates. So it means that the people doing those migration events really were avoiding release candidates. It's kind of nice to see that most people try and stay away from them. Second thing, though, is there is a cutoff point where if you stay at a certain version, no matter what you do, any upgrade path from there is a bad upgrade path. It leaves you vulnerable, it leaves you vulnerable to more work, and so on. So looking at this diagram, you can clearly see kind of a cutoff point of mostly red to mostly purple to mostly green. And what's pretty interesting about it really is if you get left too far behind, we've all been here. The next version changed an API, you really don't want to do that. Makes it harder to embed or some other nonsense like that. If you wait too long, no matter what you do, you're going to end up getting stuck in a bad path. Even if the project maintains that version, which we can see here is a maintained branch. But still, because of some API changes that affect you down the line, or some subjective rule changes, they're all suboptimal and sometimes objectively bad migrations, which leads us to this sort of thing, red streak. Let's talk about good stuff. So you see this edge of green here? That's people being in and near latest versions, right? People doing good upgrade choices. And it doesn't mean that everybody has to stay at the latest version. There are good upgrade choices here as well. So we can see, this kind of version range here around 5.1 as opposed to the 5.3 that we're in right now tends to be a good upgrade range. So it seems like there are good choices, but it's time dependent. What's good today isn't necessarily good tomorrow, because tomorrow there might be a better choice ahead for you. So it's kind of something that you have to do on a time basis. So we looked at this squiggly graph, and we looked at what's happening here, and we tried to ask ourselves: is there a good rule of thumb that you can take from this? And I will spare you the thing. We found 3 different strategies that people were following. First of all, the simplest strategy of all: do nothing. It's fine. Everything's burning around me. It's all fine. I'm fine with this, right? That we called living in disarray, which is the marketing people wanted to sound really punchy, right? So living in disarray it is, right? It means that you don't really have any standard decisions on upgrade paths. It meant that everything was done hand-cranked, and it meant that the work was really unstructured, often not scalable, took a long time. And because it took a long time, it's such a pain, people kept avoiding doing it, which meant that they kept veering off into that red zone, which is where you don't want to be. The second strategy is also pretty simple. Just take the latest. Hey, what could go wrong if you call for the latest? Definitely not dependency confusion or anything, if you remember that piece. The people that were choosing to take the latest often had the fastest upgrade path, because there's always an upgrade path to go to the latest, but they had to do quite a lot of work, and quite often, because when you go to the latest, it's always there. But there was a third strategy, which is pretty interesting, and that was living close to the edge, but not quite at the edge, not quite at the latest. And in fact, it turns out if you stay just about 3 versions behind the latest, that generally tends to give you the optimal choices for your migration. Because if something goes wrong and that version has a security vulnerability, automatically you've got a couple of extra versions that you can upgrade to. You've got a path forward. Secondly, often, if you're staying just behind the edge of an upgrade path, it means that somebody's probably found the bugs in it, and there's probably fixes. If you're at the latest and something goes wrong, let's say there's a big bug, the only option you have is to wait, right? You might waste 3 weeks doing nothing whilst the project cranks out a new release. It's up to each organization, obviously, to choose what strategy they use, but this probably is the most counterintuitive, obvious lesson that I've learned from this piece. In this case, the problem with latest is you can never be quite sure what the API changes are. When you're near the latest, you usually have enough corpus and knowledge to automate some of those decisions. It's easier for you to choose a version automatically when you know that there's always an upgrade path if something blows up, right? If there is none and you just get a pull request that says, please upgrade the latest, there might be problems. And then there's reversions. And then there's a bunch of work that you spend on a Friday that you didn't need to do, basically, what that leads up. So the ultimate best practice distilled from all of this data, n-3 version is usually the most optimal choice. Not always, but generally speaking, if you're looking for a simple rule of thumb, do things often, plan them in. Secondly, don't go to the latest, go near the latest, because if something does break up, you've got a couple of choices to go to. Typically, they're still good choices. If something's near each other, if somebody publishes 2 versions in close succession, go for the later one. And definitely don't go for things with known security vulnerabilities. So, thanks for listening in. I know it's quite a lot of data, and I'm sure you all need some coffee now. So go ahead and read the report. It's actually just a website, no registration required. Just go in there and read it. I think it's pretty interesting. And if you want to find out about more of this science that we do have a mailing list. I do recommend that you sign up for it, because it certainly comes out with new data all the time. In fact, we have another write-up of a security vulnerability coming out this week. So, thanks for listening. That's everything I had today. Cheers. Unless there's any questions, of course. Here we go.
Hi. So, the way I see it anyway at the minute, there's kind of I wouldn't say a gap, but what's your general take on the current state of how companies and, I guess, engineers can implement a secure supply chain? Because the way I see it at the minute, there's still a lot of technological gaps. So the only one I can think of at the minute, I mean, I probably, I'm not 100% certain on it, but the one I can think of at the minute is like Tecton Chains, for example, allow you to, do certain things in there to verify certain things, in accordance to zero trust. But what's your general opinion on the kind of state of, because as a method, we kind of know secure supply chains where we want to be, but technologically, with the current tool sets, you've got the Linux bill of material stuff, but there's no way to kind of read that kind of format. What's your general take on where we are and how long we are away from actually getting to that?
Yeah, so how long are we away from it being available and accessible to everybody? A little bit further away. If you have some money to put into place, the good news is most vendors today have solved many of these kind of edge cases. So I think this isn't a simple question to ask, right? Because if you think about an entire supply chain, really what you have to do is, first of all, ask the question of, on the day that I choose to download something, let's say adopt something, did I adopt the right thing? Do I have the right framework in place in order to do that? Once I've integrated it in and I've started working with it, is it still good whilst I'm working on it and whilst I'm publishing it? And then there's the third piece of the puzzle, which is once it's out the door, how do I make sure that I keep it maintained and published? So what you were saying, right? That isn't a single problem. That is actually a workflow problem that we have to solve as an engineering process. It isn't just a tool that you can bang in. In most cases, right, we tend to generalize this problem as, well, maybe I'll have something to monitor my pom.xml or package.json or something like that. And, if there's something that's, there's a newer version, we'll just upgrade to that newer version, right? What this seems to imply to me is that that's the gap. You need more data to actually back up that choice, and you need a framework around it. So from a technological point of view, there are some very simple things that we can do. For example, we're going to invest in Central, and we're going to find a way of surfacing that mean time to upgrade score for every possible choice, right? So it's available for people to see, because it's kind of an apples to apples comparison. Then you can kind of say, is it a good project or a bad project? And you can make your own call. The second part of it, though, is I think standards are still forming. SPDX, which is what you mentioned there, doesn't really have a very good vulnerability standard at all. There's another one that I personally prefer, which is called Cyclone DX. It's owned by OWASP. That has a much more defined, kind of component information category. But one of the kind of key gaps right now is persisting information about decisions that we made. So, for example, there's an alert about a vulnerability. You made the call as a maintainer to ignore it because you don't actually call it or some other stuff like that. But other people running those tools will not have that context, so they'll keep telling you about it. That's actually what a guy called Dan Abramov wrote that blog post about when he was talking about npm audit. So I think over time, that's kind of the next gap that we're going to have to find out, is communicating the decisions that we made internally to the people consuming our stuff, so they understand our justification. But yeah, it's not a one thing that you can do. It's kind of a wholesale rethink your engineering, really rethink what you're doing here, because most people probably aren't. Yeah, there we go.
Thanks so much. I really enjoyed the talk. I've just got a
Cheers.
couple of questions, if that's okay.
Go for it.
So, firstly, why do you think people overestimated how well they fix vulnerabilities?
Oh, that's great. That's easy. I mean, how good are you at writing code? You're probably the best person in the room, right?
Right. So, was it to do with the survey, or is it? Yeah. Do you think?
Yeah. So that's kind of actually, is interesting that you picked that up. That is the reason why we kind of put it on a maturity model, and we kind of gave each and every one of them titles. That being said, the dataset is only 700 people, so I guess with a bigger end, you'd probably see things go through there. But I think it's because when people are thinking about open source right now, they're thinking about security vulnerabilities and all the fire drills that they did. And probably the last one that they did, they were probably better than before. So that clearly it's more than a 3, but it's not quite a 5. I think that's the reason why it sits there.
That makes sense. And secondly, for the npm copycat packages, is there anything that should npm really have verification that there's previous versions, maybe through the releases on GitHub?
It's a very, very interesting question, and it's also highly subjective, because what you have to kind of think about there, actually I'm just going to pull out that timeline for you, because it is an interesting timeline. So there's really two things. npm argue, and Microsoft by definition, argue that it's not the job for the library to verify what gets put in the library. It's your responsibility as a consumer to make a informed decision about what you're doing. What we see is you don't have the information that you need to make an informed decision. That's first of all. Secondly, we deliberately chose with Central to implement ownership verification for this exact reason, right? And I think part of the reason why things like JCenter came to be is some people said that's too hard and that's too complicated. And I will be the first to admit Central signups could be better. And don't worry, we're doing something about that. But npm have chosen the stance that it's actually better to keep the barrier of adoption low, because it means that more people are probably actually publishing stuff. So it's kind of like a two-edged sword. You make it easier for people to share code. Turns out they're going to share code. If you make it harder for people to share code, it's going to be harder for them to publish, which means that it's harder for them to do stuff like this. So I think there's somewhere in there, there has to be a happy medium. But Microsoft security team did publish a white paper where they explicitly said that it is up to you to inform yourself, which I don't necessarily agree with 100%. No worries. Out of time. Well, thanks, everybody.